Hello, everyone. I'm Prince Bawuah, and I'm speaking to you from Cambridge, UK. So I'll be talking to you about the state of photonics and some medical applications in Ghana and the sub-Saharan Africa. I'm the president of Photonics Ghana and also a visiting adjunct professor from the University of Eastern Finland. And I'm currently working at the Department of Chemical Engineering and Biotechnology, working with the terahertz application group. So a bit of myself. I'm a Ghanaian, and I did my studies mostly in Ghana. So I did my bachelor in education, specifically science education, where I majored in physics at the University of Education, Winneba. And then from there, I started a master's degree in physics at the University of Cape Coast. And then I got a scholarship and moved to Finland in 2011, where I began my master's in photonics, and then continued into my PhD in physics at the same university. From there, I moved into the same university, but a different faculty, or different school, that is School of Pharmacy, where I did almost a year of postdoc in Kuopio. And then I moved to Cambridge in 2018. So I'll talk a bit about my work. So these videos is a summary of what I do mostly. So I mix powders together, and then I make tablets, drugs. And then after making these tablets, I do a lot of measurements, especially using terahertz time domain spectroscopy and imaging. And the whole idea is to make sure that these drugs are well formed and also function properly when we take them. So as you can see in the video, the main idea is to be able to predict the release properties of this drug non-destructively and in a very fast manner. So I have developed a method that can rapidly measure the porosity of tablets in a non-destructive manner. So somebody may be thinking about a terahertz. So terahertz is basically an electromagnetic radiation that is sandwiched between the microwave and the infrared. And as you can see, it has a lot of useful advantages that allow it to be used in this area. So we send a pulse through a tablet, and then we measure the transmitter signal, and then from there we extract the refractive index, and by using effective medium theories, we get the porosity. And then we are not just getting the porosity, we are also having an idea about the pore sizes and then their orientation. And this guides us to also understand the ingression of medium through tablets. So based on that, this method has been developed, and the outcome is that we have developed an at-line porosity sensing method, which is called TeraSolve. And as you can see here, so now we can automatically measure the thickness and the porosity, and in a very fast manner. And now I have used this in measuring a lot of tablets, both commercial and lab scale batches. And here you can see that now we can extract the porosity of a lot of tablets, and now we have a distribution. So meaning we are bringing a different definition or angle into the way of determining the quality of drugs. And from there, we can also predict the disintegration properties. So you can also see that this is a non-destructive way compared to the existing ones. Currently, I'm working on an European Union project where the target is to develop a targeted drug delivery system. And these are the three areas we are focusing on. On the ear, we are developing ear implants, and then breast implant, and then also the colon. So what I'm doing here is to use terahertz and then X-ray micro-CT to characterize these drugs and then get to know their physical properties and how they will perform when they are taken into the body. Okay, so now let's go to the main business. I will now talk about photonics, the state of photonics in the sub-Saharan Africa. And when I talk about the sub-Saharan Africa, I mean West, Central, East Africa, Southern Africa. And when we talk about photonics related activities in Africa, the North African and then the South Africa is leading. But I wouldn't be talking much about the North Africa. But then with South Africa, I think South Africa has been a leader in photonics and its applications. Since the onset of lasers in the 1960s, South Africa has labs, national labs, as you can see here. So they have research centers and then labs whereby a lot of photonics activities are going on. So starting from nonlinear optics to terahertz and then to Raman, this simulated Raman spectroscopy. I think a lot is happening in South Africa. So with South Africa, I would say they are doing very well in photonics. But then when we come to the other African, I will mention Ghana, where I'm coming from. In Ghana, I think we have a lab or a center that was built around the early 90s. And here we do most of spectroscopy and imaging. And the main idea is to use these methods in characterizing agricultural materials like farm and also for environment. Yeah. And then in Senegal too, there's a similar lab over there that was also built. Yeah, so basically, when you take South Africa outside, you can see that the rest of Africa, except the northern part of Africa, I think Ghana and Senegal is the only place where you can find these centers, like photonic centers or laser centers. But then I have been in the Ghanaian lab and I've worked there and I know the current state and I know how it is compared to the labs we see here in Europe. Yeah, there are other research groups also working on other African countries like Cameroon, Ethiopia, Kenya. Yeah, but then these are just some isolated or niche. And then they are doing some photonics also over there. Yeah, so when we are talking about some networks in Africa, so we have the Laser Atomic Molecular and Optical Science Network, which is also founded in Senegal. And I think normally they run meetings and conferences to bring together African scientists in optics or lasers. And then we have the African Laser Center that was also established in around the 203s in South Africa, whereby Africans have the opportunity to be trained. So Africans from other countries go there for training and the South African Institute of Physics. Yeah. So these are some of the networks that has existed in Africa. And then when we talk about international organization, I know of the Abdus Salam International Center of Theoretical Physics, which is in Italy. I think this has been helping a lot, and I remember that the lab in Ghana and Senegal, this was all funded by ICTP, yeah. And also the Swedish International Development Cooperation Agency have also done a lot. And some associations like Optica and OSA and SPIE has been helping a lot. For example, with SPIE, currently Photonics Ghana, we have funds from them, and then we are using this in order to impact the African continent. Yeah, so there are a lot of available opportunities in Africa. So when we talk about clean energy, Africa, we have a lot of solar energy, and then we have useful lands for agriculture. And then when you are talking about smart city, I think Africa, we are now developing so we can incorporate all these new technologies into these new cities that are coming up in Africa. And then in terms of medicine, we can also do more exploitation, for example, in the area of herbal medicine. and then internet, and then communication. Yeah. But then there are a lot that has not been done, or Africa is still lagging behind when you compare the output of research that comes out from the other world and then Africa. Yeah, I would say that it is the continent that is lagging behind, but not the African people, because when you go to the other world, you see some of us from Africa who are doing great work in this area. Yeah, so one will ask, why is this happening? Because we lack capacity. So there are limited staff. So there's a brain drain, like as you can see, most of the smart guys, due to lack of resources, we end up into the Western world and other places in Asia to do science. Yeah, and also, why is it that since there's lack of capacity, there's also lack of interest. Yeah, so most of the time you go into these physics or optics related programs at the university, and then you end up being unemployed. So all these are some of the things this is happening, and that's why we are not getting people to venture into optics and photonics related programs. And then the little lab we have also, we don't have equipment. So mostly students are being taught theoretically, and then they don't have the practical feel. So at the end of the day, they don't have the passion to go into this area. And also limited access to scientific knowledge. Sometimes it is difficult for you to get access to these journals. And also, I remember some of my friends, sometimes they publish, and then after publication, I have to access their published articles and then send it to them. So you can see that the universities, and then the local governments are also not investing into science, and especially physics related. Yeah, and also there's no internet. Even if you want to do your own studies via YouTube and others, there's no lack of. So these are a lot which is happening. So here I have proposed some way forward. So in order to attract the young generation, we need to upgrade our facilities. Yeah, we need to have state-of-the-art centers, especially photonic centers at various places on the continent. And then there should be more of student chapters. Like I remember there used to be OSA student chapter at the University of Cape Coast. And then there should be more of this workshop, outreach programs. And then I think that organizations like IEEE should also think about making accessible of knowledge free to these African universities so that they can have access to journals, and if possible, make every publication open access, and also reduce publication fees, because normally when you are publishing in most of the African universities, you have to pay the publication fee from your own pocket. Yeah, and this is very difficult also. Yeah. And also, I also encourage that Africans who are trained in the diaspora, we should start thinking about the continent and then come together as Ghana, Photonics Ghana, we've come together, and then we want to help our country and the continent. Okay, so now I'll go into Photonics Ghana and a bit, so you can see the number of problems and possible solutions I have enumerated in a previous slide. So in 2019, Ghanaians who are into photonics, we came together and formed an NGO called Photonics Ghana. And as you can see, we are well connected with almost all the universities in Ghana, and also in Finland, University of Eastern Finland and Photonics Finland. We have a website, photonicsghana.com, so you can go there to read more about Photonics Ghana. So currently we are about 35 in number, and we have 10 PhD holders and about 9 PhD students, and several master students and those who have master's degree. And then you can see us across the world. Some of us are in the US, or anywhere, and then we are working in both academia and industry. And in the industry, you see top industries like ASML and Microsoft, and also in the pharma, some of us are working in top pharmaceutical companies, and also in academia too. You can see that some of us are also in the top universities in the world. So these are our sponsors, SPIE Finsol, and then Praying, and then these sponsors have been helping us to get some funds and then to do what we are doing in Ghana. So now our team is to arouse the interest, as I said. And what can we do to arouse the interest of these young Ghanaians? So we've realized that most of the teachings are theory, so we want to introduce a bit of practicality. So we've acquired some Photonics Explorer case, and here you can see students at the university, in the university level, playing with the kits we send them. And this is also some students at the senior high school, also playing with some of the Photonics Explorer kits we send them. So the main idea is that these students, they see what they are doing and they are very much interested. And these kits are easy to use. You can just assemble them on your decks, some experiments, and then you don't need any energy. You just need maybe some batteries. Yeah, so these are things they do, and they are very much excited. And now the feedback we are getting from there is very much convincing and then promising. Yeah, so we want to enroll even more so that at least every senior high school will get access to this basic case, especially not the Explorer case only, maybe even Arduino and others, so that they will see what they are learning. And I think we are going to get more people to venture into photonics and optics. Yeah, so we are also engaged in some career seminars, trying to encourage the younger generation to venture into photonics and others. And we are not just doing career seminars, we are also running some online courses. So recently we introduced computational photonics, whereby we meet and then we try to coach young Ghanaians into this area. And also do collaborations among ourselves. So we have some published papers together. So we try to also make sure that we can do science like Ghanaians. We can also do our own science. Yeah. So we come together and then we do some publications. Yeah. So now the ultimate goal is to build a photonics center. So this year we've started a bachelor degree in photonics engineering in one of the universities in Ghana, whereby one of our members is currently a senior lecturer. Yeah. So the main idea is to introduce a bachelor degree in photonics and then get students to do this. And also by building the photonics center, yeah, we have this modern equipment whereby students and even companies can visit from Ghana and even other African countries. Yeah, so this is what we are thinking about, and then we need the international support, and then we know that this will lead into real-time solution. Yeah, we can be doing the outreach programs, but then when we don't have some sort of concrete solutions, then we may end up getting all the smart guys living in Africa, and then at the end of the day, we may not have people there to do. So one idea is also to attract foreign companies, photonics companies, into Ghana and also into Africa. And then when these students, after their graduation, they have companies to work with, employment, then nobody will tell you to do photonics. So this is something we are doing. So finally, I would like to thank IEEE and then IEEE Photonics Society for the given opportunity. Yeah, it's quite sad that I couldn't make it to Vancouver due to visa challenges. Yeah, but then I hope that next time I'll have the opportunity to join you guys, and then together we have a nice discussions. And then I also want to thank Paul and Lauren for putting together this program. I think it is a very useful program and also an opportunity to let the world know the state of photonics across the globe. Thank you once again, and greetings from Cambridge once again. Bye-bye.